In the past few months, you have been exposed to a lot of new information. The UL NIST fire behavior research, Alive training, Fireground survival. All of this has caused us as an organization to look at our tactics and procedures to take advantage of this knowledge. The goal of this presentation is to help you apply the results of this research to the tactics you use in the field. This information will help you make better tactical decisions, better predict fire behavior, and allow you to attack fire more aggressively with a greater degree of safety. In short, make you a better firefighter. More importantly, here's what it's not intended to do. For starters, we're not getting out of the interior firefighting business. Likewise, we will continue to perform ventilation. You will find there is nothing defensive about these tactics. Lastly, these are just tactics. They are not a substitute for the solid firefighting fundamentals that we all learned in the academy and we continue to develop throughout our career. This knowledge has led us to three key tactical concepts. Exterior water application as part of a transitional attack. Cooling the fire environment, or penciling the ceiling. This tactic isn't necessarily new, but the smoke layer above our heads is more dangerous than ever before, and we need to cool this with the application of water. And finally, controlled and timed ventilation as it relates to flow path. Coordinated ventilation is nothing new for us, but with the fact that fires are ventilation limited, we need to be more aware than ever of when and how we ventilate. Don't go past fire to get to fire. Historically, we have always placed a premium on attacking the fire from the uninvolved side. This was done out of a concern for pushing fire into the building. Recent research has proven this to be a false assumption. With this in mind, the objective is to apply water to the burning space as quickly as possible, whether from the interior or exterior. Water, correctly applied from the exterior, does not push fire or steam into the building. In fact, it lowers temperatures inside, it limits fire growth, and buys us more time to rescue any trapped occupants. So here's the technique. A straight stream aimed at the ceiling, as close to the sill as possible. Flow for 10 to 15 seconds. Avoid moving the stream around as this tends to entrain air. This can be done with the primary attack line prior to entry, or by a second line pulled specifically for this purpose while the primary line is readied for interior attack. Either way, this needs to be coordinated to fit in with the overall plan as directed by the division or group supervisor leading the fire attack. And most importantly, this only knocks the fire down, it doesn't put it out. Studies have shown if we don't follow up with aggressive interior work, the fire will return to a flashover state in about 2 minutes. Remember, don't go past fire to get to fire. Both of these could be hit right there from the front yard. This is going to cool the environment for any trapped occupants and increase our margin of safety as we transition interior to complete the fire attack. Here, exterior water application may or may not work for you. The best access may be through the gate on the delta side for a transitional attack, or attacking from the uninvolved side through the front door, as we traditionally have, may be the best choice. It's all about getting water on the fire as quickly and efficiently as possible. A good size up and a 360 is what's going to give you the information you need to make this decision. No one single tactic is appropriate for every situation. This fire appears to be on the Charlie side. Taking a line around back past the boat, RV, or locked gate through the side yard may not be practical. The best access to the fire appears to be through the front door. Take what opportunities the building gives you. This decision is based on a thorough size up and as much of a 360 as you can get. So here's a situation where exterior water application and a transitional attack could have been useful. This call came in as a reported kitchen fire. The fire has moved through flashover and is now beginning to extend up the side of the house through the window. The crews have stretched 2 pre-connected hose lines. The firefighter at the bottom of the screen with the red hose at this point has a charged hose line and could immediately begin engaging the fire. Since we now know that this will not push fire into the building, this would provide the most rapid means of extinguishment, would eliminate the auto exposure up the outside of the house, and would also lessen the impact of the fire on the electrical service lines that have the potential to drop down and create a hazard. By going through the front door, this crew is now in a position of having to go past fire to get to fire and have the potential of burning debris dropping down and burning their hose. The next key concept, smoke as fuel. That's a hot, flammable gas over their heads. Let's review the science behind this. The smoke from the plastics and other synthetics inside today's structures is more toxic and more combustible than in years past. This tends to produce a fire that is ventilation limited. All that hot, flammable smoke is too rich to burn. It's missing one leg of the fire triangle. We need to control this by either cooling it with water or limiting the available oxygen to prevent the fire from burning freely. Cool the hot gas layer as you enter an environment like this. Pencil the ceiling with short bursts of a straight stream. You're looking for droplets of water to return from the ceiling to telling you that you're cooling the gas layer. If you have a tick with you, by all means use it. It will help build your situational awareness to the environment you're in. Let's read some smoke. Crews are arriving at the scene of a commercial structure fire. The smoke is dense, dark, and turbulent. It's definitely pressurized. It has heat behind it. This fire is headed towards flashover. Observe the effect the initial hand line has on the fire and smoke behavior. After they achieve initial knockdown on the fire by the door, they continue to flow water into the smoke layer. One hand line, flowing for less than 1 minute from a place of relative safety, has a huge impact on the density and velocity of the smoke. During that time, a backup line is established. These crews can now engage in interior firefighting with a greater degree of safety. Notice how the crew directs a straight stream at the ceiling prior to entry. They're looking for droplets of water to return from the ceiling. This tells them that the environment has been cooled sufficiently for them to operate safely. As you continue to advance, continue to direct a straight stream at the ceiling, looking for that droplets of water to return, to maintain situational awareness of the environment you're operating in. And lastly, the third concept, controlled ventilation. Where, when, and how you ventilate can have serious impacts on the behavior of the fire. Any opening, whether a door, a window, or a hole in the roof, creates an area of negative pressure. The fire will flow in that direction. That's what's meant by flow path. Research has shown that open doors are nearly perfect for increasing fire growth. They behave like a chimney on its side. They let smoke out the upper half and draw fresh air in the lower half of the opening. It's this bidirectional flow that causes the fire growth. Controlling this opening deprives the fire of the air it needs to grow. Here's some more on the dangers of this phenomenon.
Change. This one was significant. We saw this repeatedly. from when you open the front door and begin your ventilation operation, whether it's front door and windows or front door and multiple windows, whatever it is, the reaction to oxygen is not instantaneous. There's a little bit of a delay. So in that little bit of a delay, I call it kind of the invitation period. Come on in. Things aren't that bad. You get a little tunnel of fresh air being pulled in. All right, this is the one I'm going ahead of the hose line. Well, when things started to go bad and got really bad, like 200 degrees to 2,000 degrees, was happening on the order of 10 to 15 seconds. So how quick can you run? That's what winds up happening. If you're not controlling the environment you're in with water or controlling the air, things can go bad in a hurry. This is why we see the YouTube videos of the firefighters on fire, because they were in the inlet. They were feeling pretty cool until that oxygen got mixed in there and everything lit up around them, and then it was bad quickly. So there aren't a boatload of warning signs.
Whether you force the door or come across the door that's already open, make a quick visual check for any victims near the door. Then pull the door shut using a tool to control it. Keep the door shut while you call for water to your hose line and get ready to make entry. Here's a video demonstrating the technique. Visual check, pull the door shut with the tool to control it, goes to get the hose line, gets ready to make entry. This is thermal imaging camera video from a test burn, showing the effects of door control and limiting ventilation. The number on the left in the yellow box is the maximum temperature at the ceiling. The temperature bar graph and numbers on the right are from the crosshairs in the center of the screen there at approximately the 4-foot level. They've started a fire in the left of the room, and the heat is rising, beginning to bank down off the ceiling, and you can see the level of thermal balance. Well, at this point, the room is already non-survivable for any civilian occupants, and it's rapidly approaching the levels to which we can survive in our safety gear. So in a few seconds here, the firefighter on the right there in the lower right-hand screen by the door is going to close the door. And notice the behavior of the fire. You're going to see the temperature drop, and this video is in real time. So there goes the door. The door is now closed. And notice the temperature is dropping. And this is, no water has been introduced. This is only by reducing the amount of air available to the fire. So let's take a look at some Fireground video and see how we might do things differently today. We have a fire that's ventilation limited, doesn't have the air it needs to burn freely. Don't help it out. That front door should be controlled and kept shut while you're waiting for water. Breaking out the windows will accelerate fire behavior. Don't do it. Once you have water to your line, hit the ceiling with a straight stream. Stack the odds in your favor. Cool the environment you're about to enter. Short bursts until you get drops of water returning from the ceiling. If the smoke layer is turning the water to steam, the environment is too hot. Conditions could rapidly exceed the capabilities of your safety gear. We realize these are significant changes to the way we've traditionally done business. Take the time to study some of the material that's out there. Practice these techniques on the drill ground.